Hey, good morning, everyone. Today is Saturday, 18th of January. This is our second webinar of the year. We did in the past on electrical 2 weeks back. And just to recollect, we did almost 182 webinar last year. So this year also, we are intent to bring in a lot of knowledge sharing webinars. So today we are going to talk about fire detection and suppression, how important these two. So my name is Dominic from the fire industry. I'm heading the Blue and Grey here. Uh, been in the association of many other associations. We founded many association. I'm more very closely working with NFPA, which is the National Federation of India for Electrical Safety, because 70% of the fire incident is because of the electrical fire. So I want to really understand, is it true that 70% is electrical fire is causing due to electrical fire? So I'm going around the country talking about it and what are the new standards in electrical safety. So and focus again, forum of critical error. We need to integrate entire building, especially on the fire. If you don't integrate with HVAC, plumbing, you'll not achieve the result. So very actively involved in both these society today, and we will be more vibrant this year. So go back to the second slide, Lakshmi. So today we're going to talk about fire detection, suppression, protecting high value assets. What are those high value assets? So we'll understand from our speaker. So we are honored to have our Mr. Selvakumar, who is a seasoned expert. Before we proceed, let me also want to thank Agni Controls, who come forward to share their experience, their knowledge, and the solution they have um, for protecting high value assets. So this webinar not just a presentation; it's an interaction. So I would urge everyone to post your question answer Q in the Q&A box on your menu bar on the Zoom. There is a Q&A box. I request everyone to put your question in the Q&A box. If you put it in chat box, that will not go into recording. And also wants to talk to the speaker. To me, you can raise your hand, so I will allow you to speak to the speaker. Um, so let's go to the, I want to introduce the speaker, Mr. Selvakumar. Can you change the slide, please? So Selvakumar is the second presentation that he's making, and he's a technical director at Agni Control. He's an instrumentation engineer, certified fire protection specialist, CFPS we call, from NFPA, and MIFireE from the Institute of Fire Engineer UK. So he has over 15 years of experience in industrial and critical fire protection system, wide knowledge on various fire detection and extinguishing system as per the national and international standards. Mr. Selva represent BAS CD24 as a technical committee member. He also worked very closely with various international test laboratories like LPCB, VDS, and BIS. Member of various associations including FPI, FSCA, IFE UK, and CAA for training and conducting similar knowledge workshops. So I want to welcome Selva and highlight and talk about the protecting high value assets. What are the solution available? What are the standards of talks about? And what really you do to do the same. So over to you, Selva. Can we unshare the screen, please?
Yes. So I will start sharing my screen.
Yeah.
Okay. So as I was about to explain, thank you very much, Mr. Dominic and Blue and Grey, for this arranging this webinar on our behalf. And what you said is perfectly right. So today we are going to talk about protecting high value assets. So that was a brief introduction about me. I'm an instrumentation engineer, a certified fire protection specialist from NFPA USA, and MIFireE from the Institution of Fire Engineers UK. So before going on to the subject, I would like to just give a brief introduction about Agni controls. So Agni Controls is an industrial fire protection OEM manufacturing company and a turnkey solution provider. So the company was started in the year 1985 by our founder and group chairman, Mr. D. Balachandran. He's an industrial expert and a stalwart in the fire protection industries and known throughout the fire protection industry across the world. We initially started as a custom built electrical panel manufacturer way back in 1985. And fire alarm control panels was one of the custom built panels. And that was our journey into the fire protection industry way back in 87 and 88. Our first suppression system, along with the customized fire alarm control discharge panels, was commissioned in the year 1988 at Thoothukudi Thermal Power Plant way back in 88 through Western Crompton. So that from there began our journey into the fire protection, predominantly in the gas suppression systems and customized fire alarm control panels and discharge panels. We at Agni Controls offer products and systems in the following brands. Balava series, which is gas-based fire suppression systems. Flooded series, for special application fire detectors such as heat, spark, ember, and high temperature probe type heat detectors. Balava mist, water mist fire suppression systems, including low pressure and high pressure water mist systems. And DFA series, which is tube based detect and extinguishing fire extinguishing systems. We have our presence in these following verticals: oil refineries, power generation, heavy engineering, automobiles, textile mills, and defense sectors. So without much details, I'm just showing different our customers, some important customers in all the segments. A few important customers from the power generation, heavy engineering industries, textile mills. And as on date, we export to more than 20 countries across the globe. So while many fire protection systems and products are being imported, we are proud to be exporting fire protection equipment to other countries. So today, going to the topic, protecting high value assets using Balava series gas-based fire suppression systems. So when you talk about gas-based fire suppression systems, we have carbon dioxide fire extinguishing systems, inert gas fire extinguishing systems, clean agent fire extinguishing systems. So inert gas is also a clean agent. So as per NFPA 2001, inert and chemical-based extinguishing agents both are covered under NFPA 2001. The reason why I put it separately is because inert is a naturally occurring gas, whereas the other chemical-based fire extinguishing agents are manufactured for the purpose of fire protection. So I want to clearly show a differentiation between the inert and a clean agent system. So this particular topic, high value assets, is a very big topic, and I will not be doing justice if I squeeze in everything and do it in this very small, brief time of 30 to 40 minutes. So what I'm going to do, I'm going to split this this session as two sections or webinars. So today, predominantly, I will be talking more about the carbon dioxide fire extinguishing systems. So when you're talking about high value assets, what are we talking about? So now with the diamond, with the modern technology, AI driven technology, datas, everything, all the machineries which used to be conventional are now turning into smart, and the cost of machineries are very, very high. And if your machine breaks down, of course, the entire production line or the process breaks. And the cost for a breakdown is unimaginable in many cases. For example, a refinery. The process of if a gas turbine is stripped, the power grid collapses. So you can imagine the magnitude of the assets. So that is the reason why we are calling it as high value assets. It's not just in terms of money, it is also in terms of their value. So if your power grid collapses, restoring is it's going to be a wide out blackout, and restoring it is going to be a huge challenge. So these are some of the, I've just shown some four images, multi-axis AI powered machining centers, gas turbines, paint booths, test beds. So test cells or test beds. So why is it very, very important for us to protect the machineries? Well, this is a small a machine, a CNC turning machine. And I will just show, this is a small clip. It's a 3-4 second clip. So you can watch this clip. I'll play them. So you could have seen that. In case any of you missed it, I would like to play that video once again. So this is actually a machining process. So this is how fire starts in many of the applications. Fire starts very small, and if we are not equipped to extinguish the fire when it's small, it is going to grow rapidly to other machineries and to throughout the entire building as well. Within a few minutes or even seconds, in some cases, if the calorific value of the fuel or the material burning is very high. So it is important for us to protect your high value machineries using dedicated fire suppression systems and dedicated discharge control panels designed to meet your specific machine risk. So there is no one-stop solution, or you cannot just like that, buy a common panel which is available and use it for all the applications. May work in sometimes, but may not be suitable in many of these applications. So which we will discuss in detail during the next upcoming slides. So what are we talking about in terms of protecting high value assets? Number one asset is always going to be human life. Life safety is going to be priority always. So personal protection. And the next big thing right now is the data. So data is the next big thing which needs protection. And without data, our entire infrastructure collapses. Production machineries in many of the continuous process areas, without the machineries, the entire process stops. Of course, electrical infrastructure, without power, nothing runs. And storage areas, it's an area of concern where lot of material with huge calorific values are stored. And these areas are some often neglected. Test equipment and test facilities. In many of the cases, the testing equipments or the machineries are much more expensive and critical rather than the actual production machines. So protecting all these different assets becomes our priority when we are talking about high value assets. So just for a small comparison, I have just listed out what type of system can be used in various of these protecting these assets. So where personnel is used, CO2 cannot be used, which I will discuss in the upcoming slides. Control rooms, again, it's normally occupied and it is not safe for human beings. So water will damage the equipments, so it is not used in many of these applications. Production machines, electrical infrastructure, flammable storage areas, test equipments. So here you could see that In most of these applications, a gas-based fire suppression system, be it any extinguishing agent, is more suitable for protection of these kind of equipments. So, as I told you, today we are going to discuss in detail about carbon dioxide fire extinguishing systems on how it is protecting high value assets. So, these systems are designed as per the national and international standards IS 15528, NFPA 12, VDS 2093. Again, now the real question comes CO2. When you talk about CO2, we often hear many people saying whether CO2 system can be used considering the environment. While everyone is talking about green, clean energy, clean power, clean extinguishing systems, you're talking about CO2 system. Well, today we will break the myth. And in the upcoming slides, I will show you why and how. So before going into the actual suppression system, fire is a chemical reaction giving it's an exothermal reaction, meaning that heat is released as a form of chemical reaction. This is what we call as a basic fire triangle. So this is a basic fire triangle. So any fire to occur requires combustible material or fuel, which is always available in your risk area. Oxygen is always available in our atmosphere at 20.9%. And when sufficient amount of heat occurs to ignite the combustible material, fire occurs. So, what are we going to do? How CO2 extinguishes the fire? Well, when you apply CO2 displaces the oxygen with carbon dioxide, and it also has a cooling effect. So CO2 breaks two of the three links in the fire triangle by eliminating the heat, or reducing the heat rather. It will not eliminate, but definitely it will reduce the heat, and by displacing the oxygen content below 14% to ensure that fire is extinguished. And that is how carbon dioxide extinguishes the fire. So today, when we're talking about the CO2 system, we are going to see all these 6 points. So these 6 points will give you a brief idea on what the gas suppression system is. So any system, we need to understand the physical properties. So carbon dioxide is a very unique gas where at triple point it is available as solid, liquid, and gas. So, depending on the temperature, carbon dioxide can either be liquid, vapor, or a solid. So, at room temperature and pressure, CO2 is a gas. And when you are filling it in high pressure cylinders, it is two-thirds liquid and one-third vapor. So, carbon dioxide has another unique property, which is the pressure of CO2 varies with temperature. Is directly proportional. So, which means that when temperature is low, the pressure inside the cylinder is low. When the temperature goes high, the pressure inside the cylinder goes high. So, an interesting fact is that 1 kg of CO2 will have the same pressure as 100 kg of CO2. And that is the reason why you cannot monitor the contents inside the cylinder using a pressure gauge. Unlike an extinguisher or a clean agent system or an inert system, you can measure using pressure gauges. Well, CO2 cannot be used because of these variations in pressure due to temperature fluctuations. And that is the reason why CO2 is always kept in hanging position using online monitors or weighing devices. So here you can see that all the cylinders are kept in a hanging condition through online monitors. So any loss of contents of the CO2 can be monitored through the weighing arrangement or the online monitors. So these are all some other theoretical points. I'll just go quickly. So CO2 discharges as a white cloudy vapor. So this is actually where the transition is happening from liquid to vapor. So the nozzles and the pipeline should be designed in such a way that liquid comes out and converts into vapor at the nozzles only. And this phase transition between liquid to vapor is what you see as a white cloudy fog. So if you discharge a system and you see no white cloudy, mist or a fog, you know that your design or the hydraulic system is not good. When discharged, solid minute parts to earth the pipeline and the nozzles to ensure that static does not affect it, especially in the explosion proof or flame proof atmospheres. Now, now we're going to talk about the environment. So, as I told you, we're going to break the myth, the impact of CO2 system on climate and environment. So this is a UN environment program document report on the Halon Technical Options Committee. So what the committee, this was published in December 2018. So here the report says that carbon dioxide used in fire protection applications is not produced for this use. Instead, it is captured from an otherwise emissive use, temporarily sequestering it until it is released. So, what it says is that number one, CO2 is not produced for the purpose of firefighting. So, CO2 is not manufactured just for the sake of fire protection. CO2 is a byproduct in many of the other chemical processes, petrochemical refining, sugar canes, alcohol, and CO2 is just a byproduct. So, irrespective of whether you use a CO2 system or not, this CO2 is going to be released into the atmosphere unless and until the entire refining process, the sugarcane, alcohols, and many other processes stop using it. We are not going to stop having CO2. So, that is number one. So, what we are doing is that instead of letting it go into the atmosphere, this carbon is sequestered. So, what do you mean by sequestering? Instead of letting it go into the atmosphere, we are preventing it directly into the atmosphere. We are, in fact, catching, securing, and storing it inside cylinders rather than directly exposing to the atmosphere. So, um, what we are doing is rather delay the inevitable. So that's what is happening. And the conclusion of that UN climate summit was that CO2 system has no net effect on climate. So which means that either you use CO2 system or you don't use the CO2 system, it is still not going to have no effect on the environment. It is going to be the same. So that was about, and that is the reason why carbon dioxide systems still have standards, not only here in India, throughout the world, even in the European Union, where they talk about climate change and all those things. It is not banned because they cannot directly write off carbon dioxide because it is still considered as one of the best extinguishing agents for machinery applications and normally unoccupied or normally non-occupied areas. So coming to the other point is safety. Now, here is where CO2 is not used in occupied areas because this is called as a NFPA fire diamond or a hazard diamond. So the red represents the flammability. Whether CO2 is flammable? Of course not. So it has given a 0. Yellow is for reactivity with other items. So it is 0. So it is a stable agent and it does not vaporize or react with other items normally except few metal hydrides. The white one represents radioactivity. It has no radioactivity, so it's none. And the blue one is the health. So here, NFPA has given it a 2 rating, which means that intense or continuous exposure to CO2 can cause severe injury and may even lead to death. Why? That I will cover in the next slide. But whether it is applicable only for CO2? Not really. It is also applicable for other extinguishing agents also. So, for example, the inert system and the clean agent systems, they all have something called as a NOAL level and a NOAL level, no observatory level and a low observatory level. So, the design concentration should be designed in such a way that it does not go beyond that limit. So, there are design limitations for all the extinguishing agents. So, as I told you, what happens inside the human body once you inhale or ingest? We all know that oxygen is carried in the blood cells to our brain and other parts of bodies, all the cells. So, as I told you in the fire triangle slide, that oxygen is displaced with carbon dioxide. The same happens in our bloodstream also. So the oxygen contents inside our bloodstream is replaced with carbon dioxide, and the hemoglobin turns to carboxyhemoglobin. And there is a starvation of oxygen through all the cells and including the brain. And that is why we have suffocation, asphyxiation, which you fall unconscious, and ultimately it may even lead to death. And that is the reason why carbon dioxide systems is normally not used in is not used in areas where human occupancy is always present. However, additional protection is also required. You cannot simply say that I have a machine and no one will enter. Someone has to go inside the machinery to service it or operate it, or in case of overhauling, and someone has to go inside. We cannot completely avoid the entry. So, for that, what needs to be done is to add other safety components integrated with the system. For example, we have the wintergreen odorizer. Wintergreen odorizer is contains a wintergreen oil, which is similar to your axe oil or an eucalyptus oil. Very strong, pungent smell. So, if you are not able to hear the alarms, or if the electrical system fails, you can't, hear the flasher or the hooters, the strobe horns. Anything won't work. But gas is discharged for some reason. You can get that strong smell even in the adjacent room. If somewhere CO2 is leaking, you know that somewhere gas has leaked, and you can evacuate the area. So this is something which is used in the machineries to notify people that carbon dioxide gas is released somewhere. Manual lockout valve, as I said, before entering the machines, the pipeline has to be completely isolated to prevent the human discharge when human is inside the machinery. And CO2 evacuation units to extract the CO2. CO2 is a very dense agent, which means that once it is discharged, the gas is going to settle at the bottom. So when you are discharging a CO2 in an underground cellar or an oil pit or somewhere underground, the CO2 is going to be present in the down level. And you want to extract the CO2 into the atmosphere so that it is safer for human entry. So all these are other safety equipments that are also available to be integrated with the carbon dioxide system, even for the machinery applications. So coming to the design basis, CO2 systems are available as high pressure systems and low pressure systems, depending at the storage of temperature. As I told you, at high pressure cylinder means it's ambient temperature, so not exceeding 49 degrees Celsius. It is stored in cylinders, which we normally use here in India. Low pressure systems are used for bigger areas where a refrigeration unit, a big bulk container, is required. Constantly, refrigeration units are required to maintain the CO2, the entire tank, at minus 18 degrees Celsius, so that the CO2 is maintained at 20 bar pressure. The running cost of the low pressure systems are very, very high. And therefore, that is the reason why we don't use low pressure CO2 systems. And depending on the risk area, the system is also designed as a total flooding system or a local flooding system. So, what is a total flooding system? Well, as the name suggests, the entire risk area or the room or the machinery void is completely flooded with CO2, and the overall oxygen percentage inside the room is brought down from 20.9% to below 14%, thereby extinguishing the fire. So, wherever your nozzles are, wherever your equipments are, the total area, the entire volume is considered, and the overall volume is brought down below 14%. That is, I'm talking about the oxygen content. So, we are talking about the overall volume. So we have to consider the openings. If there are any closable openings are available or ventilation ducts, all those things needs to be considered. Even if there are interconnected, if you have a room next door and it is connected through a small door, it is also recommended to consider as an interconnected volume, and the volume of the total area needs to be protected. And local flooding. Local flooding is for areas where it is not entirely covered. So consider a room, two sides or three sides are closed and one side is completely open, and it's open into a very large warehouse or a factory building. You cannot provide the total flooding for the entire warehouse of thousands of square feet or meter cube in volume. Here the nozzles are provided in such a way that it targets directly on the risk application. For example, you are protecting a rolling aluminum mill. The nozzles are positioned in such a way that the liquid part of CO2 is directly discharged on the actual fire risk areas like rollers or drums or wherever fuel lines are going. So thereby here we will have more now a number of cylinders or more quantity of cylinders rather than the total flooding system. So, depending on the risk area, the cylinder systems are available in various configurations. Main, main and standby with directional valves for multiple area protection. Initial and extended discharges. Initial and extended with main and standby with directional valves. So these are the different types of configurations. So main is used for primary protection of the risk area. Main and standby, primary protection with 100% online redundancy. Main and standby with directional valves for multiple area protection using a common cylinder bank. Initial and extend as per the standard recommendation. When it is used to extinguish fire in a rotary energized electrical equipment, you need to give an initial discharge which will quickly extinguish the fire within 60 seconds, and then extended discharge varying from 5 minutes to 40 minutes or even to 1 hour depending on the machine which is protected. So the purpose of the extended discharge is to keep the volume, the oxygen level below 16% for as long as possible. So once you, okay, which I will explain later on. And the final one is the initial and extended with main and standby with directional valves. So for our understanding, I just put a small, schematic configuration of the main bank. So this is a compact CNC machinery where we have two nozzles and a single cylinder. So only one single cylinder is protecting this machine. Here you can see that when we are talking about the fire extinguishing systems, we are not just talking about cylinder, pipe, and nozzle. This is a system, and the system requires early fire detection, a discharge control panel, and the evacuation units. The tripping, everything has to work in tandem to successfully extinguish the fire. So it is not only the cylinder or the pipeline or the nozzles, it is the entire system which has to be perfectly designed. So here, this is a main and a standby configuration. We have two cylinders as main and two cylinders as standby. Here, once if two, for some critical areas, customers or many applications, they feel that they don't want to have a risk. So if two cylinders are discharged, it has to go out for refilling and come back. So during that time, the standby cylinder will be kept in online mode so that there is no downtime for the extinguishing systems. This is a main and standby cylinder bank. of protecting various risk areas using a common cylinder bank. Here, we have designed a 5-cylinder bank main, 5-cylinder bank standby, protecting 5 different risk areas: risk area 1, 2, 3, 4, and 5. All of these pipelines are connected to directional valves through various pipelines and nozzle arrangements. So, wherever there is fire, that particular area alone opens and gas is distributed only to that network. So subsequently, if the other bank also, if another area also requires, the other bank will also operate. So this was the initial and extended discharge, which I was explaining previously. So this is a turbine protection. So for turbines, it is a rotary energized electrical equipment which runs in several thousand RPM. So once you trip an RPM in case of fire, it is not going to suddenly stop like a light or a light. For example, your fan, when you switch off the fan, it's not going to come to a zero instantaneously like a light. So it's going to come down slowly to a zero position. So imagine, a gas turbine running at, maybe 5,000 or 6,000 RPM to come to zero. It is going to take somewhere between 20 minutes to 30 minutes. So this is also the similar application, rotary electrical equipment, main and standby, using directional valves to protect multiple risk areas using a common cylinder bank. We have a main bank 4 cylinders and a standby bank 4 cylinders. This is acting as the initial discharge. Whereas extended discharge is also available. Here, the extended cylinder quantity, you need to know that it is not always same. Extended cylinder quantity is actually designed, as I told you, based on the duration of discharge required and the volume we are trying to protect. So, what are the factors that we need to consider while calculating the quantity of CO2 that is required? Number one, the volume, what you are going to try to protect. What material or fuel is available inside that risk area? Any area specific risks like any explosive proof atmosphere, or any openings or any fuel lines that needs to be tripped, all those things, openings that cannot be closed, ventilation systems which cannot be shut down, temperature of the protected areas, all those things shall be considered. So here the and unclosable openings, and if the anticipated loss of agent is more than 40% of the risk volume, the system shall be designed as a local flooding system as per the NFPA. And as per VDS, it is just 2%. So if your unclosable opening is more than 2%, you need to design the system as per local flooding as per VDS 2093. So we're talking about flooding factors. What is a flooding factor? Flooding factor is nothing but the quantity of CO2 required per meter cube of the volume. So all these details are clearly given based on the test results in the IS 15528 table 3 and NFPA 5.3.2.2. So, what are the other factors that we need to consider? Volume, temperature, loss, material conversion, and deep seated fire. So, a deep seated fire means that the surface fire, there are two types of fires: surface fire and a deep seated fire. So, deep seated fire means on the surface, it may seem if the extinguishing has happened and it has completely extinguished. Whereas underneath the surface, it will still be, the fire will be there available, present inside, below the subsurface. And once sufficient, the heat has gone, the heat has come up, it is going to come into fire again. So, deep seated fire requires additional concentration as per the standards also. And what I would like to insist that never ever design your system based on bill of quantity. So, how many times have we experienced that? As fire protection specialists, that your BOQ comes and you are asked to quote as per BOQ. I would suggest to many of the experts and the people who have participated in these events, if in case you get a BOQ and you have been asked to quote, please ask them to send the design data, design the system as per the requirement, and then only quote. This is my humble request. And the hydraulic calculations, just to validate whether your CO2 system is designed properly using licensed and validated VDS softwares. So we are just going to take a small case study and an application. So here, this case study is a fire protection required for a machine which is collecting flammable dust through pneumatic duct arrangement. So what we need to ask the question first is whether this machine is accessible for personal entry. Well, these are dust collector machines and manual entry is not possible. So it is a no. And again, the next question, primary question would be, what are the type of flammable material which is available inside the machines? These dust collectors will have filter bags inside them, often made of cotton or any other synthetic material to filter the dusts. And what is the volume inside the machine? That is the risk area we are going to protect. Now, let us say, for an example, this volume is a 56 meter cube of volume. So here, the volume of the risk is 56 meter cube. Let us consider the design temperature as ambient 30 degrees Celsius. The minimum design concentration or the flooding factor that is required is 2.66 kg per meter cube. So this is as per the standard table which I have given here. For specific hazards, it is already listed there. So what is the quantity of CO2 required? It is 56 into 2.66, which comes to around 149 kg of CO2. It is always safe to consider a 10% leakage factor through hoses or any nipples that you have not properly tightened during installation or any other reasons. Always consider 10% leakage factor. So multiply that into 1.1, you get 163.9 kg. Here we generally use 45 kg CO2 cylinders, that is 68-liter water capacity. So you might consider, so what I've done is I've divided by 45 and I got 3.6 cylinders. So which is approximately around four numbers of 45 kg CO2 cylinders. So you might consider, okay, I can use maybe, three numbers of 45 kg and one number of 34 kg, just to meet the direct requirement. Well, the standard does not permit that. Mix of various sizes of cylinders is not permitted in the same bank. So standard does not clearly, permit us to use various water capacity sizes inside the same cylinder banks. So that should not be done. So this is a typical schematic drawing of what area we are trying to protect. So this is the machine which is going to collect the dust. So here we have an inlet coming out. We have a damper which is normally open. We have filters which prevent the dust from going into the other process areas. This is the outlet. So this is a typical schematic drawing of the entire system what we are going to have. So here, as I told you, we are not just talking about the four cylinders that we have just designed. We have to discuss in detail how the entire system works. Now, flammable dust explosion is a very, very serious issue, and dust can, in many times, can lead to a devastating fire. So generally, we go for room protections or other things. We go with a cross zone fire. Here, since the risk area is very, very sensitive, we'll go with a single zone fire. So a heat detector has detected fire, and it's giving signal to the hooters and alarms to alarm the people. A signal is given to the dampers to close the damper to prevent further air coming inside, and a 24-volt DC signal to trigger the CO2 systems, master and slave. And once it is discharged, the pressure switch gives a feedback back to the panel saying that gas is discharged and the gas is actually released inside the atmosphere. This is a typical flow or the operation of a carbon dioxide fire suppression system. So just for the benefit of everyone, I would just like to, play this animation once again. Tripping signals, 24-volt DC to the cylinder, main master, Master in turn operates the slave. Gas is discharged, presses which feedback is taken to the panel, gas is released. So why I was talking about the entire system is that if you don't trip the dampers or any process line or a fuel line which is coming inside the area, the CO2, once it is going to discharge inside the risk area, is going to go out directly through the inlet and the outlet ducts. Thereby, fire will not be extinguished inside the area because the volume is very high. So you need to contain the volume first and then extinguish with the extinguishing agent. So this is the typical application what we have seen today. So the control system should be designed to support fire suppression system, meeting the requirements. As I explained many times, it's not just the cylinders, it is also the entire control system. Early fire detection is very important. Choose right detectors for the right application, which we have seen in the previous webinar, and we will also cover later on also. The design of the fire suppression system shall be based on the hazard identification and the risk assessment. As I explained before, there is no one-stop solution for everything. Each risk has to be assessed separately. Interlocks with the other processes which may affect the performance of the system should also be provided. For example, if the door is opened, the CO2 system should not be discharged. Or if if the CO2 is discharged, the incoming fuel lines or the HVACs, everything should be tripped. And all these things, whether once you have designed, how to validate, how to know whether what you have given is actually working in the field. You can validate using the concentration measurement method. So post discharge, you can measure the residual oxygen level inside the risk area to know that your oxygen percentage is below 14% after discharge. So if it is 14% after discharge, you know that your system is perfect and it is going to extinguish the fire at any cost. And coming to the final part, which is the most important part in my view. So, in many cases, post handover, the systems in many cases are designed perfectly, installed, commissioned, and handed over to the customers. So, what happens post handover? The users, we need to educate the users to let them know what they need to check for. Whether the cylinders have a valid PESO certificate, it is a mandatory requirement as per the Indian Gas Rules Act. So if valid matlab, it's like 5 years. Every cylinder has to be hydro tested once every 5 years. So if there is a need to be hydro tested, it has to be sent for refilling, discharged, refilled, hydro tested, and sent back and recommissioned. So it is a mandatory requirement as per the gas cylinder rules of India. Visually inspect all the components and check if the components are fitted. In many cases, I have personally seen they would have tested or discharged the system. In case fire would have happened, the cylinders would have been discharged. They would remove the cylinders, send it for refilling, and they bring it back and reconnect. In many cases, we have seen that the cylinders are not properly connected, or rather connected to, there are several valves which have a separate filling port and a separate discharge port. The hoses are wrongly connected to the filling port rather than the discharge port. So that in many cases, the customer is not aware on what to do, and therefore ultimately when fire happens, it's not going to put off the fire. And also customer changing the internal volume of the risk area. So there would be a sudden expansion plan, so they would have increased the volume by, maybe instead of 56 meter cube they would have gone to 66 meter cube. For them it would be just a 10 meter cube volume. For the fire suppression system it may not be efficient. So that is also something that we need to consider post handover. And also, as I explained, that we need to equip the customer to handle the system. This is a high pressure system. To handle, operate, and maintain the system in case of emergencies. So, a brief SOP, standard operating procedure, has to be provided near every risk area or the cylinder bank, detailing almost everything possible to help them in order to do a maintenance, what they should do in case of emergency, how to operate, in case the panel is dead, how can the cylinder be manually triggered, everything. All these details have to be provided to the customer. And of course, training, which is very, very important. Not only train the heads of people, we have to train the people who are down level. Even if they are available in three shifts, all the three shift people have to be trained properly on the handling and how to operate in case of emergencies. So it becomes very, very important for us to equip the customer to handle the system ultimately, because they are the users. Okay, so with that, I have come to the conclusion of the webinar on protecting high value assets using carbon dioxide as the first part. And on 3 days, 4 days back, on the 15th of January, Honorable our Prime Minister Sri Narendra Modi has commissioned three naval vessels, INS Surat, Nilgiri, and Bakshir. And we are proud to say that our extinguishing systems protect the engines of the mighty P-17 Alpha stealth frigate, which is the INS Nilgiri. And Agni Controls is part to be proud of this prestigious defense project. Our equipments are mill graded and JSS Penta 5 approved. And with that, we have become the first Indian company to successfully indigenize the fire protection system for the warship navies. Previously, it was from the Russians. So I take this opportunity, and I have that's my time. I thank you so much for listening to me patiently, and if you have any questions, we'll take it forward. Thank you so much.
Thank you, Selva, and also congratulations for securing and protecting INS Surat and INS Nilgiris as a very prestigious installation, or probably the Make in India in our warship. Congratulations, Selva. Okay. Now moving forward, can you hear me, Selva?
Yes.
Okay. I'll take up the few questions that is there, and those who want to speak to the speaker, we have 20 minutes, 25 minutes. We'll keep 15 to 20 minutes for question answer. And those who want to speak, you can raise your hand. I will, based on the timing and the convenience, I will allow you to speak. But your question should be relevant to today's topic only. Okay. So I'll take up the first question from Murugan MGK. He's asking the difference between CO2 system and N2 system.
Okay. So the CO2 system, actually, it is nothing but the extinguishing agent is different. CO2 displaces the oxygen. Basically, the extinguishing principle, CO2 displaces oxygen, and whereas nitrogen system or the inert system dilutes the oxygen content. So more amount, our atmosphere is present with the 70% of nitrogen. So you are purging in more nitrogen inside the same volume. So what it happens is it increases the volume of nitrogen more, thereby reducing the concentration of the oxygen level below. And there are many differences. For example, the CO2 I have shown was white. When it's discharged, it's white fog in nature, whereas nitrogen is colorless, is odorless. So even if it's discharged, there is no visual obscuration, or you can escape carefully. And CO2, when it's inhaled, as I told you, is very harmful for human beings, whereas nitrogen is available in the atmosphere, and it is safe when it's designed properly for personnel. So N2 system can be used in occupied areas also, whereas CO2 system cannot be used in occupied areas. So that is the primary difference. And yeah.
Thank you, Selva. The next question.
Good morning. This is Arun Kumar Balachandran. So I'll just join for the Q&A session.
Okay.
So just one point I just like to add to this, to Selva's answer, is that the carbon dioxide is a very efficient agent in fighting the fire or extinguishing the fire, whereas the nitrogen, though it is efficient, it is not as efficient as a carbon dioxide. And that is the reason why for machinery protection, we use carbon dioxide because it's the amount of CO2 that is required to put off a fire is very less. And the amount of nitrogen we need to put off the same volume of fire is going to be very high. And that is one of the additional information that we need to give. And the second thing is the operating pressure. For a CO2 system, the operating pressure is going to be 50 bar pressure. For inert, it can be at 150 bar, 200 bar, or 300 bar. So it's going to be a very, very high pressure system. And people need to be very careful in handling a high pressure system.
Oh, thank you for the clarity given, Arun. The nitrogen, which is inert gas, is 150 bar. It's like a live bomb in the protected area. So, and CO2 is most for machinery. Of course, CO2 is the best solution and occupies less space here. Anyway, Nitin, question is from centralized CO2 bank to the outlet more than 10 meters away, can we get the same flow or high pressure which is adjacent to outlet of the bank?
Yes. So here we are talking about gas suppression system. So 10 meters is nothing for a gas suppression system. So you can, clearly you can get, if the pipelines are properly designed using, the hydraulic calculations, and you can simulate using the, VDS design softwares, you can get the same flow, the orifices, the pipe sizes, the inner diameter, everything can be adjusted to get the uniform flow for all the nozzles. So it is possible. 10 meters is not a big issue.
So again, just to add to Selva's answer, so in gas suppression for carbon dioxide and inert system, okay, the agent, it is driven by the vapor pressure of its own content. For example, in carbon dioxide system, as Selva explained in the earlier presentation, inside the cylinder, CO2 is in two-state form. That is, 2/3 in liquid form and 1/3 in vapor pressure. So when we open a cylinder, inside the pipeline also, the CO2, it runs on a two-phase form. The vapor pressure will push the liquid up to the nozzle point. And as Selva rightly said in the presentation, it is the liquid CO2 which captures the heat in the risk area, converts into vapor, thereby it is making
Cooling effect.
The cooling effect. One is taking away the heat. Second is replacing the oxygen, and it immediately extinguishes. And this is the reason whenever we design a centralized system, it can be 10 meters apart, it can be 20 meters apart. We can even go for a distance of 50 meters also. But the point is, we have to design the pipe size and the nozzle orifice code in such a way that we get the liquid CO2 to the maximum point, so that the oxygen content is brought down from 20.9% to less than 15 or 14%. And in this aspect, we also have the chemical gases, that is like the FK5112 or FM200, which are basically propelled by the nitrogens which is filled in there, which can be up like 25 bar or 42 bar. But the thing is, as per the design aspects, any chemical agent, which means any chemical gas suppression system, which can be FM200 or FK5112 or NOAC, which is commonly called, it has to be discharged within 10 seconds, which means it cannot travel a very large area from the risk area. That's why most of the larger areas are mostly avoided designing with the chemical systems. And for example, the data structures are now, the large data structures are using only either inert or waterless systems, which I think Selva will take later.
Okay, so what Arun is saying is, engineering is very important. Like what Selva said, you have to have a flow calculation, the right calculation to be done. And Arun is saying proper engineering is very necessary, piping engineering is very necessary to achieve the 100% result. So You can't have anybody and everybody to offer the solution unless you have this expertise. So let's move on to the Anand question. In case of false alarm, what is the scenario in the CO2 system?
Well, it depends on the control panel and how the detectors are connected. So, if you're talking about a critical application, if you feel the machinery is much more important rather than cylinder quantity or CO2 discharge, it depends on the standard conveniently says one word called as AHJ, if you refer, which is authority having jurisdiction. So, which means when you are the user, you are the process owner, you know better whether your machinery is much more important or CO2 is much more important. So, if you feel that the machinery is much more important, they would go with a single detection. If only one detector is operated, they'll release the CO2 without any time delay. So when you have, when you feel that it's not that important, you don't want accidental discharges, normally you go with the cross zone discharge, where zone 1, zone 2, or a combination of two or more detectors are used for gas discharge with sufficient amount of time delay. Well, accidental discharges should be avoided through the control panels and the designing of how the detection systems are integrated. So that is the only option.
So I'll take a live question. I'll take up first, Praveen. If you are listening, you can put up your question here.
Sir, I'm Praveen Istane. If while extinguishing the using the CO2 flooding system, there will be chances of reignition in case of liquid fire. Then how is it possible to use any other extinguishing media in such a case?
Sir, I think it was also covered in my point. When you're talking about oil fires or something, we have something called as a deep-seated fire. So for deep-seated fire, generally 40% more additional quantity of CO2 is taken. And whenever you have more areas, the standard also recommends wherever reignition is possible that you go with an extended discharge also. So in areas where you feel that there is a if the risk area requires that reignition is possible, it is always recommended for initial discharge to extinguish the fire within a minute, and then extended discharge to keep the oxygen level below 16% to prevent reignition until the risk area is completely cooled down. So, yeah, that would be anywhere between 5 minutes to 10 minutes or 20 minutes, depending on the risk area.
Okay, thank you. Thank you, Praveen. Next question I'll take up from Ravinder. Ravinder, please go ahead.
Yes, sir. Hi, Mr. Silvaras. So my concern is here, the CO2, and nowadays in market, so many brands are available, like FE227 and FE K5112.
Yes.
So because of global warming, so still we can use the CO2 flooding system.
Sir, I think I've made my point very clear because CO2 system, that is the myth what I wanted to break in this particular session. The this data saying that CO2 cannot be used is completely a myth, and there is no if the CO2 system cannot be used, then what is the purpose of having standards and all those things internationally? So it can be used, as I explained, as per the UN Environment Program Technical Committee on Halon Replacement, published in December 2018. CO2 system has no net effect on climate, and it is used. It is permitted to be used. Whether you use a CO2 system or not, has no effect because carbon dioxide is being released into the atmosphere even through the beverages we drink. So it is unavoidable. What we are doing by using CO2 system is that we are just delaying the release of CO2 into the atmosphere. Here in cylinders, what we are doing is we are containing the carbon dioxide rather than being directly exposed to the atmosphere. We are just holding it, and we are going to release only in case of an emergency or a fire condition. So CO2 is not going to be, it's not going to be banned like many other halons, which contributed more to the ODP and the GWP. So that is my point on that, sir.
And just to add a point, sir, so the two agents you mentioned, both are chemical agents, which are specifically manufactured for firefighting. And of course, they have their applications, and similarly, they also have their limitations with respect to environment also. So if you take the environment, it is not exactly zero affect to the environment. And if you are very much want to have a zero very clean agent, then inert is going to be the best option rather than a chemical agent.
Okay, let's move on to the next question from Tejveer. He's asking, what are the standing pressure of CO2 cylinder and impact of temperature?
Okay. Sir, the what is the MOC of nozzles? Nozzles are generally we use aluminum to prevent corrosion, and in some cases where aluminum cannot be used, it is preferred to have stainless steel nozzles, either 304 grade or 316 grade if it's on corrosive atmosphere or marine applications. So yeah, nozzles shall always be made of non-corrosive materials like aluminum or stainless steel, or sometimes brass with plating. Velocity through the nozzles, of course, it depends on the pressure and the hydraulic network. So this is not similar to our water spray system where we have the flow. The gas suppression systems, the flow rates are completely different than the flow rates of the water systems. And with respect to temperature, consider 30-degree ambient temperature. This container pressure, cylinder pressure would be around 60 bar.
And
Sorry.
just to add the point. So the nozzles of especially CO2 would be in a cone manner to form uniform distribution and as well as prevent icing, because it's where in the nozzle, it's orifice, it's where the liquid CO2 is going to turn into vapor. And if that is blocked, then the discharge won't happen. So that is one of the critical design of the nozzle, which have been taken care by us as a manufacturer.
Let's move on to Sudarshan questions. How often should these systems be tested and maintained to ensure their effectiveness?
Yes. Okay. All the fire protection systems needs to be tested. The standard clearly gives a brief instructions like what to test every week, what to test every month, what to test maybe quarterly or semi-annually or annually. So generally when you're talking about testing, number one would be to visually inspect whether everything is properly connected and it's all healthy. If you feel something is disconnected, it has to be reported immediately. And the other thing, as I said, would be the monitoring the healthiness of the control system or the control panel. So if there are any troubles or any fault, it needs to be addressed, and the system has to always be kept in a standby position. And battery is very, very important as per the fire alarm requirements of IS 2189 or the NFPA 72 or EN 54. So the system has to be, what we have to maintain is as per the suppression system standard as well as the fire alarm standard. So both these things have to be taken into consideration and form a common list of maintenance checklists as per the site specific requirements.
Okay, Thotad Yogeshwara, if you are there, please speak on to, you can take up the question.
Yeah, Yogeshwar speaking.
Yeah.
Yeah, it's very wonderful session. Of course, I joined late. The CO2 operation system, in case of any fault, either in the latest digitization with the help of the AI, can be enhance the system operation efficiency. Anyone, Ms. Arunkumar or Selvam?
You're asking whether IoT can enhance the performance, is it?
Yeah.
Yes, any equipment, IoT or the next level of IoT, which is AI monitoring everything 4.0. Now that is also changing. So in all these cylinders, all these points can also be taken up to the cloud, and whether your one cylinder is empty, all those details can be brought onto the cloud, and can be monitored. So digitization is
Is
going
it
to
a
be.
system? Have you done anywhere such kind of application
Well,
with the help of
so far we
IoT?
have not been approached to do that kind of things, but we are open to do that. So if there is any opportunity, we'll definitely grab and do that.
Yeah, if it can be done, I think you will be another
Yes,
pioneer in
yes.
that
There,
field.
there are, there are. It is being done through many other
Hmm.
systems using cloud,
Hmm.
and yeah, it can be integrated. Yes.
Because now
All we require is a permission-free contact.
digitization is the era of the application in the fire safety
Yes, of
management.
course, of course. Yes,
Yeah.
yes. Yeah,
And
it can be.
second point,
Yeah, it can
yeah,
be integrated.
yeah, you please go ahead. I think that will be the wonderful design, and you will be the again pioneer with you will once again PM will invite you.
Yeah, thank you
Thank
so
you,
much for
thank
kind
you,
words.
Yogesh.
And second,
Thank
Mr.
you.
Salam, one small clarification. Do you have any
Yes.
come across measuring the weight of the CO2 systems? Physically, all the cylinders, as per the standard, if it is a 10% less reduction, the efficiency will come down. Do you have any kind of a system with automatic, we can able to measure it? What is the quantity of gas, digitization, or without any disturbing the installation?
Yes, yes. So maybe you have missed my presentation. So I would like to just,
Yeah,
uh, you
I
know, sh
joined late. I joined late. Yeah,
yeah, I
yeah.
will just share my screen.
Hmm.
Where. So here, all the this is only for CO2 systems, and in previous days, even argon used to have weighing devices like this. So all these cylinders are kept in hanging position through online monitors or weighing devices like this. So we can, or have a mechanical device with using a counterweight as per the old systems, or using electronic weighing units like these, which have a normal indication saying that the system is healthy, or in case of 10% of low weight, it will show a low weight alarm on the device. And all these things are maybe if there are 20 cylinders, all the 20 cylinders are connected to a common control panel. It can be connected with your addressable system, or your conventional fire alarm system, to
It
show
measures
that.
the all the cylinders, or it is the individual. Can you get the reading of individual
See,
cylinders?
yeah. So here you can take a reading, but what happens is that when you take a reading and show a digital display of the weight of each cylinder, it falls under the meteorological department of India, and you to calibrate each and every reader or the instrument which is showing the display once every 6 months. So it is as good as removing the cylinder, putting it on a weighing scale, and again record and put it in this hanging position once again. So that is not going to solve the problem, and that is the reason why we've not gone ahead with the showing the displays. This weighing unit has a calibrated spring action arrangement
No, no,
inside,
no,
which is
I
designed
understood,
for
Salamji.
10%.
My doubt is you are giving the total of the installation system. I want to know your individual cylinder. Do you have any such kind of a individual cylinders without disturbing,
This
without
is
taking out? I can get
yes.
the
So this
individual.
unit is for each cylinder. It is for
Ah.
individual cylinders only. This one. So any
Mhm.
individual cylinder which is having less than 10% weight loss, that cylinder will be indicated. And depending on our, we have two models. One model where we have the individual LED display. So it will be having two two LEDs, one for normal indication green color and one for orange, check for refill.
Okay.
So if there is a 10% loss in let's say cylinder number 3, only that unit will show the orange color.
We understand by pressure gauge only. Am I correct?
Not pressure gauge. This is a weight
Hmm.
monitor, which is
Actually, we will get the weight also. What is the weight?
not weight. So we it is all since the standard says 10%. So let's say if we are using a 68-liter water capacity, the maximum filling that can be done here is 45.4 kg, which means if there is a 4.5 kg loss, I need to show a low weight indication. So all our units are calibrated to give a 4.5 loss output. So that is how it is
No,
there.
I agree, sir. My point is, I agreed.
Any individual weight that needs to be given. So like Selva said, it comes under a Weight and Measurements Act. And
no, it's okay. Well, that is all statutory things are there. That's a different question. My point is that can it give a correct what is the loss of individual cylinder? How much CO2 is lost?
Yeah, but that is not
Giving
required.
a loss of when it goes beyond the 10%. Okay, fine.
Sir, Yogeshwar sir, we will, what I'll do, I'll ask Selva and Arun to get in touch with you directly, maybe over the phone in distance, because we have another couple of more questions.
Fine. We will have a personal
Yeah,
call.
they will have a direct interaction with you, sir.
Okay, fine.
Thank you for coming, sir. Ganesh is asking why clean agent is not useful for flammable material storage area.
So again, sir, clean agent is again a chemical agent, and flammable, mostly it's a class B fire on different types of fuel that can be NFPA and other type of fuels. So depending on the type of fuel and the type of agent and the decomposition that the chemical reaction is going to give, it is going to be used. So widely, if you say it will not be on a proper state we can say that all clean agents can be used. So we need to go in with individual clean agents, which means there are currently about 8 different clean agents. Most predominantly, we know only HFC 227 and FK 5112, which is FM 200 and NOAC 1230. But we also have other agents such as FE13 and FE36 and other agents are there. So we cannot just a blanket wise say that all clean agents can be used for class B or a chemical or a flammable fire. That is the reason.
Just to add on that, if your calorific value or the fuel is more, and if you're talking about an extended discharge or a deep-seated fire, your clean agent system gets discharged within 10 seconds. So what will happen after the once fire reignites after 2 minutes? So for that purpose, the risk has to be assessed, and we cannot give an open statement saying that all clean agents can be used everywhere. So it has to be designed as per the risk requirement.
And mostly for this kind of applications where class B kind of applications, foam is one of the better options that is available for suppression of fire.
Yeah, for the time is the essence here. We have a couple of more minutes to go. So I'll take quick questions on Bhavik Patel is asking if cylinders are PESO certified, will it require a hydro test every 5 years?
Yes, sir. So the PESO certificate, once you receive, even if it's brand new cylinder, is valid only for 5 years. So in the PESO certificate, the front sheet itself, they clearly give that this is valid up to so and so date and year only. So after that, it is required for us to go for a hydro testing and recertification through PESO approved hydro testing stations.
So this is as per the gas cylinder rules of PESO. So as per their gas cylinder rules, once the hydro test the date is passed, then after each refilling, before each refilling, the hydro test has to be done and taken a validity. So mostly the validity will be for 1 year after the 5 years. And as Selva said, it has to be done only by PESO approved testing agency. We cannot do it at other places.
Okay, let's move on to Kiran questions. The room integrity test to be done. In this case, what is the standard procedure for critical rooms?
For CO2, the standard does not explicitly recommend a room integrity test. Of course, if room integrity test can be done, it is very, it is good because we know what amount of agent is lost and sufficient amount of carbon dioxide can be used. For inert systems, room integrity test becomes mandatory because we need to know whether the volume is maintained and whether once it is discharged, the agent is discharged, whether it is capable of keeping the content of oxygen below the between the low L and no L level. So yes, and I didn't get your question regarding the critical thing. What is the procedure? Maybe you need to elaborate a bit more for me to understand,
You
sir.
must be asking for the clean agent. Anyway, we'll clarify that later. Shekran is asking, is any fire system recommended by you for textile spinning mill? I think Agni Control are, they have one of the largest installation for textile spinning mills. So I would ask Selva and Arun to get in touch with Shekran directly, and probably you can interact and give them a solution. Second, yes, because I'm just speaking on behalf of Agni, saying that they are one of the largest supplier for textile mills. Okay, so
Yes, sir. Sir, you can just take down our contact details so that we can have a discussion with you on a one-on-one basis.
we already have some several of the details are there. We'll give you. So Santosh is asking, there will be need for fire detection and extraction system. I need to know the detecting of rebar with IR light and UV light. Can you take that question, Silva?
There will be need of fire detection and extraction system.
Extraction. I don't know where they need. We need to
Um,
detecting rebar.
Santosh ji, if you can just, maybe,
Email.
elaborate. Yeah, maybe just clarify. I'm not able to understand the question. Maybe just if you can clarify, we'll be able to understand a bit better, sir.
See, Selva's mail ID is mentioned in the chat box. So those who are listening, and Santosh, Selva's mail ID is mentioned in the chat. You can note down or take a screenshot and write to him directly. So, what is active fire? It's all basic, very basic. I will not take those questions. Anything? Can DCP be used in electrical fire other than CO2?
Yes, DCP can be used, but CO2 once it is discharged, it ventilates into the atmosphere. So pretty much, the ventilation time is, once if it's ventilated well, so you can enter the premises or restart the equipment within a few minutes. Whereas if it's DCP, cleaning up the mess is going to be a huge task. So it's all powders, potassium carbonate and all those micro powders, yellowish powders. So cleaning up is going to be a huge task, and that is the reason why for electrical, if it's a small fire, DCP extinguishers are okay. For the bigger systems, we generally don't recommend, or customers don't prefer to go with the DCP extinguishing system because of the cleanup process, sir.
Okay. Gangadhar is asking what kind of detection system we use for steam turbine.
Well, Gangadhar ji, we are one of the OEMs for many of the steam turbine manufacturers across generally for steam turbines, it is they go with high temperature probe type heat detectors, or that detectors in a cross zone, maybe in 120 degrees Celsius or 150 degree Celsius. They will go with the cross zone. Of course, it depends on the OEM who is manufacturing the steam turbines. So, for example, BH has their own specifications. G, they have their own specifications like that. So yes, sir. So those are the detection systems, and it is often integrated with the carbon dioxide systems.
So Gangadhar then is asking the PESO certification is mandate for DLPA fire suppression like electrical panel. Is it mandatory?
As of now, if it is a low pressure system, it is not mandatory, but this is going to become mandatory.
So I will just clarify on that, sir. So any extinguisher need to have a ISI marking. Right now, peso is not a point here because any low pressure peso is not coming into that. But ISI marking is definitely has to be there for any extinguisher. So DLP is now coming out. The Bureau of Indian Standard is now coming out with a standard for DLP,
Dedicated standard.
dedicated standard for direct low pressure tubing system. So under that, ISI marking will be mandatory. So currently it is not, but maybe by end of 2025 and 26, we'll be having the standard and ISI marking will be made mandatory for the direct low pressure systems.
So Ganesh, I look like he's from airport. Ganesh is asking what type of suppression system is used for the ATC tower, especially on CNS room of airport.
But the best solution would be an inert system. So, considering the criticality of the risk area, the extinguishing system, the clean, nature, and maybe we need to understand how big the ATC tower and the CNS rooms are, and then only it can be assessed. But going from the just this. Two words, I would maybe recommend inert system because there is no visual obscuration in case of discharge and all those things. But it needs to be checked along with the user with the drawings, all those things. What are the other risks, everything. So yes, sir. So that would be my point. I don't know if you'd like to add anything.
Yeah, Ganesh, a very interesting topic is coming soon from Agricultural Selva. So we're going to talk about detection, protection in critical areas like data center. So the next knowledge that is must be on 14th, 14th at 4 o'clock. We will be talking about data center critical room protection. So that is scheduled on 14. Maybe you can invite your colleagues also. We will be sending the invite. We will talk on this, especially like you're asking about ATC tower and CNS room. It's a part of critical. So we'll elaborate. Selva will specifically talk about that subject, how to protect critical rooms, especially data center and other critical rooms. So with this, we have concluded the today's session is exactly 1 hour 30 minutes session that we have taken. There are a lot of questions also in the chat box. What we do is, Selva and Arun will come back to you personally. Those questions that we not attended or probably answered, will get back to you directly. And those who want to talk to as a manufacturer, Agni Controls can directly. There is a mail ID. And we will also send you the details of Agni Controls, whom you can talk to them, take the solution, take the design from them. They're one of the, as I know, they're one of the oldest firefighting and manufacturer design company in India, highly technical company. How many years now since Selva, your father, you're a second generation. Your father has been
Yes.
a
So with this 2025 coming, this is our 40th year into the industry. So we will be celebrating our 4 decades, completion of 4 decades this year.
Yeah, the 4 decades. It's not just 4 decades in doing business, but they have been gurus for many of the today's fire experts that you find in Middle East and India. His father is Mr. Balachandar, who is also my colleague in founding the FSA, Fire and Security Association of India. So his father is highly respected, highly technical person. And Selva and Arun, there's both of them continuing the legacy of the father to carry forward good work that has been done. So I would thank everyone patiently listening and joining. And we had a good turnout. I'm very happy and happy that we are coming back to you on 14th again on critical protection. And our knowledge series on electrical fire, electrical safety will continue along with the fire detection protection. So we are intended to do almost another 200 webinars this year, and we'll be bombarding with a lot of information to your mailbox. So please do not put me into the spam box because we come only for knowledge series, and Blue and Gray is committed to bring the fantastic knowledge series. So continue to look at our emails, and this all something that we can share to people what we learn, and we want to share it to them. And Make in India is something that we are proud of. Agni Control is absolutely Make in India company. So we would like to see Agni Control as become pioneer in this fire protection engineering solution. Thank you, Selva, for joining today. Wonderful session. You had many appreciation I can see in the chat box, congratulating for knowledge. And Arun, thank you. Balsandar sir, I know you must be there around. Thank you very much. Final conclusion remarks from you, Selva.
I think it's been a very brief. I mean, in fact, I wanted to be very brief, but it has been a very elaborate session, I believe. And as I told you, this is not a fire is not a very small subject which we can discuss within half an hour or 1 hour or even a whole day. So it would require frequent training, knowledge sharing. Everyone has to work with everyone else to together we can only together we can create a fire safe environment for everyone to be safe and healthy. So with that, I thank you all. I thank you everyone. Thank you, Mr. Dominic and Ms. Lakshmi, for organizing this, and thank you all for the participants who has come forward on this weekend to join us, and we look forward to share more of our knowledge through the upcoming webinars. Thank you so much.
Thank you, Selva. Thank you, Lakshmi. Thank you, Navya, for back-end support. Thank you. We look forward to see you, Selva, again on 14. Stay safe. Have a wonderful weekend. Thank you. Bye-bye.